Welcome to the Digital Responsibility Podcast. There is a vibrant community around the world exploring how we drive forward digital innovation, products and services, and generally exploit technology progression for the sustained benefit of society and the planet. On this podcast, you will hear from me, Christopher Johnson, and Rob Price, two of the original founders of Corporate Digital Responsibility, as we speak to our guests to hear their stories and piece together what it means to be responsible in the digital age. If you'd like to learn more, take a look at the website, corporatedigitalresponsibility.net. Hello and welcome to episode 6, series 5 of the Digital Responsibility Podcast. Thank you for joining us today. In today's episode, Rob and I are joined and really privileged to be joined by Matthew and Sadas. Let them introduce themselves. Matthew, do you want to go ahead first?
Sure. So, hi, everyone. My name is Matt Sekol. I work at Microsoft as a Sustainability Global Black Belt. And what that really means is I work across a range of companies, our customers, and I talk to them about sustainability, data and disclosures, and ESG, and try to pull out the intersection of those topics with technology.
Brilliant. Thank you. Sadas?
Yes. So I'm Sadas Shankar. I am currently in SLAC National Laboratory and Stanford University. I'm an adjunct faculty professor in material science and engineering. Before that, I was at Harvard in the School of Engineering and Applied Physics. And before that, for 20 years, I was at Intel, leading an effort called materials design. It was a new effort that we proposed and started this. And one of the things we did as part of this effort was we removed lead, 100% of the lead from microprocessors. So some of those lessons that we learned, that how you can use technology for sustainability, is something I hope to bring into the conversation, if I may.
Brilliant. Thank you very much. And how amazing to have both of you joining us today on the same call. We're really excited about the conversation. The first part that we want to explore today is around measurements in the field of ESG and our ability to measure the productivity of the software and the technology that we're using out there. So I'm really interested in your take on the array of measures that are available to corporations and how they can navigate that world of measuring what's becoming a more and more important part of their footprint on society.
Okay, so I can talk with. Maybe let me kind of try to start from the AI discussion, because
Sure.
Artificial intelligence is on everybody's mind. So if you look at it, AI is something that has really crossed a tipping point in terms of application. People are excited for the first time as to what it can do. Not everybody quite understands the power of it. Literally, people don't quite appreciate how much electrical power it needs to train these models. So if you were to look at it, there are 3 different trends happening in the society today. The first trend is everything is getting digitalized because of the internet and the ease with which you could access data. The fact that we are all talking from different parts of the globe almost effortlessly, like we are in the same room, is digitalization. So everything is going into digitalization as the first perspective. Then the second perspective is the global warming. It is not, we have unlimited access to energy from the sun, much more than we would ever be able to use. So energy is not the problem, but how we use energy is part of the problem. Because we use it very inefficiently, then what essentially that does is it generates subsequent steps that essentially creates this warming and global changing. A simple way to think about it is we are putting a lot of energy and chemicals and materials into the atmosphere. This is bound to make the atmosphere very unpredictable. Where you're supposed to get rains, you get a lot of heat. One part of the United States, for example, the East Coast is under severe storms. Another part of the United States is under severe drought. It's the same country with 3 time zones. This kind of a disparate thing was a little bit more unusual before. So that is a second trend. The third trend is we have found out, because of the power of computing and the access to data, complex systems can be analyzed by artificial intelligence methods. It is a simple way of looking at it is you really don't need to understand the mechanical engineering of an engine, and you still can drive the car without knowing how the car works. AI is in such a phase now. You don't really need to know what is needed for AI, but you get to use it for all kinds of things. The positive aspect of this is you can actually solve complex problems that would be very hard to solve, let's say 10 years back. You can solve them relatively easily. The downside to this is we don't quite know what are the limitations, both technical limitations, ethical limitations, and societal energy constraints that this AI is bringing in. So there are these 3 trends happening, whether we like it or not. One of it is happening with a lag. Global warming is the consequence of the start of the Industrial Revolution from over 100 years back. And the rest of it is also man-made. So this is a situation now. We can either say that things will get better, but as a scientist and an engineer, I just don't see how things will get better if we don't do something about it. And governments cannot solve this problem by themselves. And I can talk to this later after Matt get a chance to get his thoughts in. It needs private companies who have a little bit more grounded in good for the environment is actually good for us.
Absolutely. Fascinating. Absolutely. And in the past, we've referred to some of those factors you highlight there around the energy consumption of technologies, kind of the hidden cost of digitalization, but it's becoming less and less hidden in that respect and more impactful on the planet. I'm interested, Matthew, in your experiences of how that realization about the impact of technology is coming across in the corporate boardroom, and how that conversation has changed in recent years.
Yeah, absolutely. As you would imagine, Microsoft has a lot of great relationships in IT. And so a lot of the conversations I have with sustainability people happens in IT, people who are trying to figure out really what we call governance, right? Technology has a governance model. It's very much an ESG thing. And a lot of attention is being paid attention to from the sustainability perspective. And what companies are finding is that there is that ecosystem, not just the energy use, but to Sadas's point, also the component manufacturing and the things that go into the manufacturing of the equipment in the data center. Then you got the energy kind of in the middle when it's operationalized. And then at the end, you have this e-waste, like where does the server go? Where does the storage go? All that has carbon emissions, all that has water use, waste. If you're running a data center, it has land use, very much an environmental impact. And so what I find is, companies are trying to, this should be of no surprise coming from Microsoft, companies are trying to offload a lot of that to a cloud provider, whether it's us or, one of our competitors. And what they're finding is that, and this is what's a little bit surprising to them. When they talk to me, I talk about, well, Microsoft and the other cloud providers have built not only things like renewable energy contracts, which are kind of like table stakes, but operational efficiencies to really drive as much out of the equipment as possible, because it impacts our reporting absolutely in scope 1 and scope 2 and even scope 3 with the manufacturing. But we want our customers to be running sustainable workloads in a sustainable cloud, because that's the way things are going. Oftentimes, though, what I find in talking with IT is that they're not quite there yet. They haven't, either they haven't quite gone on the cloud journey, or they haven't quite gotten to the place where they're like, there are technologies in the cloud that can help me drive these workloads more sustainably. And so it's always a surprising conversation to see where it goes. The other thing I'd add is, real quick, to Sadas's other point, data is at the core of a lot of these. He called out 3 trends, but they're really interconnected trends. Like, even though each one hits individually, very much interconnected. And when it comes to addressing it, the thing that I think I'm not seeing yet is the breaking down of data silos, both from an internal company perspective, but also, to Sadas's point, between companies, governments, regulators, stakeholders. Breaking down those data silos in a meaningful way to really drive sustainable improvements, I think, is what's going to come next.
Can I just pick up on a question around that whole topic area, really? Because I had a conversation a couple of years ago with an organisation, and a guy said, "I've got this great tool that kind of measures emissions in the shift to cloud." And I said, "That's fantastic. Kind of tell me more about it." And we had a series of conversations, and in the end, he said, "Well, yeah, okay, it's a bit of a sales tool, but and I guess my question is, as an organisation, how do you know what's right? So if there is a right, because I mean, in the context of measurement, we can ever improve the measurement, but how do you actually know that there's something that's stated with some degree of authority rather than a sales tool?" And I'm not knocking the sales tool, because it probably was in the right ballpark, doing the right kind of things, but how do you give that tool an authoritative status?
Yeah, Rob, it's a great question. We have, I don't know who you talk to, but we have a tool for that. We, as a customer supplier of cloud, we have basically an emissions impact dashboard, it's called, that tells a customer our scope 1, 2, and 3 emissions for their usage. Now, we back that with the IEA emissions factors, which are licensed, and we have a white paper that we publish for calculation models. However, to your point, I think it started very much as kind of like a sales tool, like, look at these great sustainability benefits. But this tool's been in market for I think at least since 2018. When 2020 hit, that tool really became like, our customers shifted around the tool. Now they were like, Microsoft, you need to tell us the emissions that we're using in your cloud, because we don't have visibility into that. We don't know what you've done. And then we had this tool, and we were like, you know what? This is actually a science-based tool. This can actually not only be a selling tool, but like, it tells you what your emissions are. So here, use this tool, and this is what you can use because we're your supplier. And really, we didn't change the tool, but the intention of the tool changed as data and disclosures became more prevalent out in the market, and procurement teams were now scrambling to figure out what their scope 3 emissions were. It was, now, nobody's ever asked me that, but now that I think about it, it's a fascinating question, and how that evolved without us actually shifting the tool itself. Yeah.
Indeed, I guess it's gone from provoking conversation to being something that's needed to be depended upon as part of core business process.
Right.
Absolutely. Sadas, I'm interested in your take on Rob's question.
So there was a little bit of a due diligence I did for the US Department of Energy into looking at what tools are out there. And I think Matthew actually elaborated on the tool that Microsoft is working on. And there are quite a few companies which are trying to do it. So think of this from a Fortune 500 company. You can pick any metric you want. companies are for profit, right? So whatever they do either has to be bundled under their R&D budget, because I was in a corporation before, or it has to be their profitability bucket, right? R&D doesn't have to be profitable, but their products have to be profitable for companies to have a viable business model. So any tool that any companies develop are towards either of those two things, right? I mean, there may be other uses to it, but so one of the things how this could become quite useful is it has to move into some sort of a neutral territory, that company A is not thinking that what B is putting out makes B look attractive in a given metric as opposed to A. Now, if you transfer this whole tool, I'm just talking about the tool, into a totally neutral territory, then they don't have any skin in the game. So there is a trade-off. I think one of the things, this is a segue into one of the things we are trying to do is we are trying to put together a whole platform and tool suite, trying to look at sustainability for computing. And the reason we are doing it is a couple of companies have requested us to do is because we are a neutral research institution and a university. And the second thing is the science in the computing is advancing so fast. You know, I worked in a semiconductor company for 20 years, but I have not seen this kind of a pace in the kind of innovations that are happening in the AI and the architectures and things like that, in addition to the technology. And I saw a number, I think it is from IDC, that a 1% change in the index of computing, and I want to make sure I'm telling you the right number. When the computing index increases by 1% on the average, the GDP increases by 1.8%.
Wow.
You know what this means. Every country, 8 billion of us, wants to go all computing, because you have a very strong correlation that if you think about it, you change something 1% and you get in return 1.8%. That's a pretty big, for a GDP to move that much with computing. It's incredible, right? So we are not going to be able to stop the tsunami of computing taking over every aspect, because it directly correlates with your country's economy, which is correlated reasonably with well-being, not that well correlated, unfortunately. So it is for individuals like you and Rob's organization to show the light on these things, where the issues are and what they are, right?
Is that not a brilliant argument for, okay, that's a GDP, that's a growth kind of argument, but coming back to the broader ESG bit, if our thinking is the use of that technology can drive improvements in environmental issues because we can solve climate change through the use of that technology to gain insight or societal benefit, is that not a brilliant argument for finding a way to extend the value of ESG such that the organizations are seeing that as important as growth and money?
Absolutely. So in fact, your point is, in fact, I would argue, I mean, a little bit heuristically, your argument is the biggest thing we have going in our favor. These tools are so powerful. We can actually turn them around and use it to solve the problems that we have caused as a civilization, right? We have caused this. And I have the numbers to back up why I'm saying we caused it. The numbers are mind-boggling. But the thing is, how we are using the tool is not very clearly well defined, Rob. And let me kind of try to explain. There is one very big vendor who makes some of the most advanced computing, I will not mention the name, said that they are doing a whole lot for the environment. They're actually simulating the global climate much more accurately than it has been done before. So at first sight, it looks like, oh, that's very good for the environment. But actually, if you dig a little deeper, it's actually bad for the environment, because the energy spent to simulate the environment is really very high. So you are creating a problem on the way to supposedly solving it. So how you use these tools is actually bad. It has to be done with a lot of forethought and deliberation. If you don't know how to use it, you are nicking yourself and nicking others. You have this very powerful sword and you're turning it around, and it's not actually solving, it's not cutting the right thing, it's cutting the wrong thing.
I had a conversation with, I won't say who it was, but somebody who was working on not the standards, but kind of like one of the nonprofits around carbon emissions. And I said to them, I asked them a question. It wasn't even AI related or modeling related. I said, what do you think just gathering emissions data globally does to storage and compute? Like just that alone. Rob, to your point, if we're only doing disclosures, at the end of that, all we will have is a bunch of data. We have got to move past disclosures. We have to get comfortable. Allison Taylor, I just heard her say this weekend. I was listening to an interview with her. Companies have to get comfortable saying no to some of these data requests if it's not relevant to what they're pursuing. And they actually need to pursue I love that word, improvements. And I'd add one more to it. So improvements against existing systems, but also innovations in new areas to see where they can drive things. Otherwise, all we're doing is spinning our wheels. We have to do disclosures so stakeholders can understand. We have to move past it though and do actual improvements in innovation.
And I sense that when we consider disclosures and the nature of our mandated requirements, we come back again to the relationship between government and the private organizations and the inbuilt tension between those two entities, especially related to the skin in the game that you mentioned earlier, Sadas, and how we're able to drive both a best interest of the planet conversation alongside a best interest for investors and other type of metrics. I'm interested, I'm conscious of time, in the what you both consider to be the next frontiers for ESG and in supporting where the corporations across the world need to go here. So that's, you mentioned earlier this tension between private and government. Is that where you'd pin it?
Yeah. So actually, so I will go back to history on the lessons I learned when I was working for a company, Fortune 500, a leading semiconductor manufacturer. From the late 1990s and early 2000s, lead was used 1% as part of the solder in the packaging in what is called a flip chip technology. And that 1% lead elimination was not thought to be something very important. European Union in the early 2000s was saying that you have to remove lead in order for you to sell in Europe. There was no regulation yet. The US, of course, was willing to give us a regulational exemption because we were one of the biggest semiconductor manufacturer in the country, in the world. And a few of us thought that we can actually solve the problem by using technology. So we had a team which actually designed materials to design the lead out. Okay. And we actually got it out in the 45 nanometer technology, in the same technology generation in which the Intel microprocessors went into MacBook Air. So we got the innovations, but we designed it out. So why did I go through this? Just to make the statement, the way to do that is not by regulations. The threat of regulations works as well as the regulation.
Sure.
The threat of shining a light on companies works as well as the actual punishment. So you don't have to be punitive. You could use the threat of a stick. And then the carrot is actually using the same technology to design for sustainability. So what the effort that I am involved in with the US Department of Energy is to design computing to be energy efficiency as part of the design cycle, not as something that you fix after the problem is. So that seems like a win-win because companies like to innovate. That is in their culture. Companies like Microsoft and all are innovating all the time. So if you say that let's design for as part of the innovation, but for sustainability, it is more attractive with the stick that there would be an impending regulation if you don't change it. These two work. When I was an insider in a company, these two work well, and then people make a difference. It cannot be a top-down thing. Matthew, for example, probably is doing a whole lot as an individual, running around, talking to people, and bringing the ideas. You are actually running the podcast to shine a light on this. These things matter, but these by themselves won't solve it. You have to keep shining the light because people have a tendency that if you take the light out, then I will go and do what is best for profitability, right?
Absolutely.
I could definitely build on that. I think so. I'm going to do a shameless plug here. I'm actually writing an ESG book, and I just wrote the chapter on the future of ESG. So the timing of this question is perfect. One of the things that I came to realize in writing the book was companies thrash a little bit about this topic, but something Sadas said about how each of us has unique capabilities to shine a light in only the way really that we can is the realization that I think companies will come to. Every company on the planet has intersections with the E, with the S, with the G, that only they can impact in the way. And I know we talked a lot about the environment this whole time, but I'll give you some social examples. Really just a simple one from us, which is a couple years ago, we started putting more attention on accessibility of our digital products and our hardware products. And so if you look at our products today, you'll find things like the Xbox adaptive controller for people. And so there's a kit for our Surface devices where we're adding in adaptive capabilities as well for people with limited mobility. But we also do things in our software, like if you think about, I don't know if you've seen this, but now there's artificial intelligence built into things like Power BI to help coach you as you speak and present, or real-time translation in our Teams platform for, meetings and things like that. All of those really help build accessibility into the digital experience. So it's not just about the E or the S or the G. It's about what are the things that your company is doing to help better improve your stakeholders, whether it's people or whether it's the planet, because only your company can do it that way.
Fascinating. Yeah, that's really interesting. I'm glad you brought in some of those social examples as well, because they also represent some of those dynamic areas where innovation can drive so much value for the common individual day to day. And so much of our focus across digital responsibility is about supporting those people out there.
So
brilliant.
I have a certain numbers which is interesting to kind of say this. There are 8 billion of us humans. The energy that we spend for just survival is of the order of like 0.9 terawatts. That is the energy. And we all weigh approximately about between 400 and 500 million tons. The energy we consume is 16 terawatts, approximately 20 times more than we need for living. The materials we consume approximately 60 gigatons for 8 billion of us per year. Okay, that is 138 times more in weight than our collective weight. And we consume of the order of something like exabytes of information every year. I call this the price of civilization, to get an idea how much we are using nature's resources.
Sadas, I remember us talking, and you gave a brilliant example around energy efficiency, and you were talking about deconstructing viruses and a supercomputer versus a human. Would you like to share that? Because I just thought it was a really interesting challenge.
Yes. So I mean, this is actually mind-boggling. So in order for us to say that COVID has infected us, per cell, there actually needs to be 1 million virion particles from COVID. That is typically how much the infection is. It's a little bit higher than that, but 1 million particles per cell. Okay. And they actually looked at the energy that COVID takes to infect. You know that your body temperature increases by a few degrees because you get fever. Mm-hmm. And that fever is not coming from the COVID particles infecting, it's from your immune system responding. So it is the energy that body needs to do that. So you go up by approximately 3 to 4 degrees, and then you have to take antibiotics or you have to take the thing to bring down. To simulate a single COVID particle, the energy that it took, just 7.5 microsecond of a single COVID particle, it took an order of 1 billion joules on a supercomputer, okay? And this COVID, I kind of joke this, the COVID does not have access to the supercomputer, but how is it infecting millions of people? So are we actually solving the real problem when we say we are computing and solving it? And even if we are we not doing it much more inefficiently than we have to? Those are the questions. The virus itself seems to be taking minimal energy because they couldn't even estimate it as a fraction of a single cellular energy. And we have about 37 trillion cells in our body. So it just boggles my mind every time I look at this graph I have. How come we are being this inefficient when we say that we are understanding what the particle is doing, when the particle itself, the virion itself, is much more efficient? That's the example. So there's something wrong with this picture. Just because we have the resources, I have a feeling that we are using it without a lot of deliberate forethought. There are more intelligent ways, and we need to put thought into it. So energy can be, if you constrain energy, you will be more innovative in how you will use it. That's why startups tend to thrive much more than big companies. In big companies, I used to joke that I had unlimited resources when I was working for a company, right? I could almost move things fast across the world. So in where resources is. But then you look at the startups in Silicon Valley, they have 1,000th of 1,000th, 1 millionth of the resources of the R&D budget. Intel spends between 10 and 20 billion a year on R&D. But those companies are coming up with nicer ideas. So constraints, my feeling is nature is probably the most innovative system. when you constrain it, more solutions appear than when you give it a lot more resources. So this is just a plug to say startups may be a big component of this equation that we haven't talked, and they can solve problems in the most innovative way because they are resource constrained, and nature is always resource constrained. Always.
Indeed, absolutely. Matthew, I wanted to come into you very briefly before we conclude the session today. If there's any messages you'd want to leave with our audience about really where we need to see progress next, and what your key focus area is at the moment.
Yeah, sure. I think from my perspective, it's really trying to get my key message at the moment is really right what Sadas said, like try to make sure that you're running as efficiently as possible. I hadn't come across that COVID stat before, but it points to a very serious challenge that we have, and questions that we need to be asking that maybe IT isn't set up for. Questions about ethics, right? Like the ultimate. So I graduated with a liberal arts degree, so I love exploring those questions, but not everybody who's in technology has. So seek out diverse perspectives, integrate efficiencies as much as you can into your models. Like if you do move up to the cloud, which obviously I would be thrilled if you did that to Microsoft, make sure you're running those workloads efficiently though, because we want to run not only our own workload sustainably, but help our customers do it more sustainably as well, because like Sadas said, everything's resource constrained. Yeah.
That feels like a really positive way to end today's session. Thank you so much to you both for your involvement in today's podcast. It's been brilliant, and you've both been really articulate. So thank you. And thank you to everyone for listening to today's episode. We'll see you all next time.